All right, hello, and welcome back to Real Seekers. I'm your host, Dale, the Real Seeker, and I was just playing my for John Loken. John Loken has complained, and others have complained about the length of my intro song. So I've done some editing, and now it's a nice short 40 seconds. So I hope you guys enjoyed that. But yeah, welcome back to Real Seekers. We're continuing on with the Shroud Wars series, and this time we're going to be looking at ordinary naturalistic mechanism. So just for the audience, you'll remember I categorized there are three different types of explanations for how the Shroud images were formed. So on the first place, obviously, as Hugh is here as a Shroud skeptic, the ultimate Shroud skeptic, like the most on the left side, I guess, of Shroud skepticism, they take an ordinary artistic mechanism. A medieval artist used some kind of artistic technique of one sort or another to purposefully create the images as a piece of art. Then we have on the other end, on the right end of the extreme, people like Bob Rucker, who take the extraordinary, or dare I even say supernatural mechanisms, things like radiation or divine photography, things like this. But today, we're going to be dealing with theories that fit into the middle. So these are things like Kelly Kearse would fit here, or Barry Schwartz. And they think that the Shroud is historically authentic, but the images aren't supernatural. They can explain naturally by just positing a dead body or corpse being covered by the Shroud and letting the laws of nature take over. And natural mechanisms can, in one way or the other, explain the images. And we're going to be covering three of those. So the first will be direct contact. The second will be gas diffusion, specifically focusing on the Maillard reaction and some of Dr. Kelly Kearse's recent findings about adding in the skin effect. And then finally, we're going to be looking at Dan Spicer and E.T. Toton's electric charge separation model. So that's what we've got on the agenda today. But just before I get into that, let me introduce the players. So we have Bob Rucker immediately to my right. How's it going, Bob?
Hello. Thank you for having us.
Now, I'm noticing something different. You're not in your usual surroundings. Is there something going on? Or are you?
well, yes, my wife and I are down in Longview, Texas at this point, visiting my son and his family, and I am speaking to you from his spare bedroom.
Excellent. Yeehaw. So awesome. And we also have, of course, everybody's favorite Shroud skeptic or non-authenticist, Hugh Farey. How's it going, Hugh?
Oh, it's fine. It's been rainy all morning, but it's now 6 o'clock in the evening and the sun has come out and it's baking hot.
Okay. Get rid of all that wetness. All right, awesome. So, yeah. And just so the audience knows, unfortunately, I received an email just yesterday, last minute, from Brian Donley Worrell, who was supposed to be on also on the panel. And unfortunately, he had some kind of a family emergency. So he's going out to Arizona to take care of that. And that's why he was unable to show up. But I'm hoping we can make it up and he'll be on the next Shroud Wars panel there. So yeah, with that said, let's get straight into today's topic. And the first thing I want to do is spend some time just discussing the good old-fashioned direct contact mechanism. And can this be used as an explanation to explain the Shroud images? Why or why not? So I guess, Hugh, I'll start with you first on this one. What's your take on, what is the direct contact hypothesis and some of the variations that have been proposed on that front? And how do you think it performs in terms of explaining the Shroud images?
Okay. Direct contact imagines that the cloth, where there was an image on the cloth, it made contact with something, which might have been a dead body, it might have been a bas relief, it might have been a statue, it might have been paintbrush. The thing that people say, which mitigates against this, is that the Shroud shows graduations of color, which if you simply slap a piece of cloth or paper down onto a surface, you'd get color where it made contact and you wouldn't get color where it didn't make contact. And so the hypothesis is that the contact mechanism is therefore impossible. However, since we non-authenticists think the contact mechanism is in fact how the shroud happened, we could explain that the tonal graduation doesn't necessarily have to be caused by spatial distance from the substrate to the cloth. It is, I mean, in terms of a graph, it seems to be correlated, but it could occur because if you imagine, well, there are two ways really. The first way is pressure. So if you imagine it was a statue made of sponge, and you laid a cloth over the top of it, and you then pressed down, where you pressed a lot, you'd get a lot of liquid soaking out of the sponge. And where you didn't press much, you wouldn't get much liquid soaking out of the sponge. And so you might get a graduation in tone, which was not related to distance, but related to pressure.
Now, would that be the same principle? Because obviously we're talking, by direct contact, we're talking about natural theories just involving a body, not a statue or something.
But even if it was a body, if you imagine my face, and you put a cloth over it, and you just press down firmly with both hands, then down the sides of the nose, you wouldn't be pressing very hard.
Gotcha.
But on the surface of the nose and the eyebrows and the top of the forehead, you'd be pressing quite hard, so you'd get the full contact there. Whereas where you weren't pressing so hard, such as down the sides of the nose and perhaps underneath the moustache, there you'd get less contact, and so you'd get less transfer.
Gotcha. Perfect. Okay. And okay.
You said gotcha as though you didn't really get me at all. Does it make sense?
No, it makes sense. I get what you're saying. It's the same thing, John German, Samuel Pellicore, they supposed certain forms of pressure or like the dampness of the cloth to kind of make it conform and stuff like that. So, right? Okay, awesome. So, Bob, I'll turn it over to you. Kind of what's your take on direct contact as a natural mechanism, not an artistic technique, but that, and the variations people have proposed. And what's your general take? Do you think it can explain the images that we see?
No, it can't. And I think it's easily rejectable, simply because, as Hugh mentioned, that if the cloth were laying over the face, and if it was in contact with the nose, it would not be in contact with it coming down either side of the nostrils. And if as Hugh seems to assume here, that each fiber were infinitely flexible, that you could in some way then press down on it equally around, then you'd have folds in the cloth which would show up on the image, and that's contrary to the image itself. So the image itself has to be, the mechanism has to be transported across empty space from the nostril to the cloth, which is above the nostril at that location. So it can't be due to due to contact. Now, in my analysis of this, what I'm doing here is that my paper 39 that I'm now writing is going to be on evaluation of various image formation hypotheses. So number 6 here is for the contact. And I have 6 different contradictions with the evidence, and then also 6 different things that would have to be explained by a workable contact hypothesis. So that there's so many objections to this, it's hard to talk about them all. And the same thing with the Maillard reaction, which we're going to be getting to. Okay,
and did you want to maybe just quickly list what those 6 things were? I'll just read them. I don't know. It covers about a page here. So I said, number 1, the tip of the nose would have been closest to or in contact with the cloth above the body. This explains why the fibers are discolored to a
extent at the tip of the nose. However, there's a smooth gradation of discoloration down the nostrils where the cloth would not have been in contact with the body. This smooth gradation of discoloration, even where the cloth would not have been in contact with the body, is a general feature of the shroud. This is not consistent with the image being formed by contact between the body and the shroud. This is because at each point on the cloth, there is either contact with the body or no contact with the body, so that the process that causes the discoloration is either 100% on, where there is contact, or 100% off, where there is no contact. This is inconsistent with the smooth gradation of discoloration that is on the shroud. That's number one. Number two, there are about 100 linen fibers in a linen thread. A linen fiber is about 15 micrometers in diameter, which is about 1/5 the diameter of a human hair. And a fiber that is discolored, in one of the images, the discoloration on the fiber has a thickness of less than 0.2 micrometers. That's the typical value that I see people quoting, with the discoloration around the outer circumference of the fiber, so that the inside, that is the non-discolored inside, would be about 14.6 micrometers, compared to the 0.2 thickness of the discoloration of the flax fiber is not discolored. If this discoloration of image fibers were caused by a chemical reaction due to contact between the body and the cloth, then the fiber should have been discolored through the fiber instead of just around the circumference of the fiber. So in other words, the contact hypothesis doesn't really explain the thinness of this discolored region, and doesn't really attempt to. Number three, the image on the shroud contains 3D or topographical information related to the vertical distance from the body to the cloth at each point. This is not consistent with the images being formed by contact between the cloth and the body. So if the cloth were in contact with every location on the body, then you'd have zero vertical distance between the body and the cloth. And that's not consistent with the evidence. Number four, the shroud does not include images of the sides of the body or the top of the head, but these images should have been formed on the shroud if the cloth were wrapped around the body, and if the images are due to direct contact. So the images are wrong. I mean, everything is wrong. Number five, the image on the shroud of the face is a normal width for a human face. If the shroud were wrapped around the head and thus in contact with it, the image of the face on the shroud, when it is unwrapped and thus flat, would be much wider than the normal face. This evidence of the width of the face on the shroud indicates that the cloth was not wrapped around the head, but rather was relatively flat and some distance above the face during the encoding of the facial image. This indicates that the facial image was formed by some process that extended across the air gap between the body and the cloth, which also disproves the direct contact hypothesis. And then number six here of my contradictions, images can be seen on the shroud that include bones near the surface of the body. This includes the area of the teeth, that's how I say it, hands, backbone, and possibly the skull. Now, I say area of the teeth because I'm not convinced that we're actually seeing teeth there. We may be seeing an interference pattern due to the wave nature of the radiation that's coming out from the body to the cloth. It is not clear how direct contact between the body and the cloth could cause the appearance of bones in the images. And then I go into 6 items that a convincing direct contact hypothesis would have to explain that I don't think the current concepts actually do explain. Okay, maybe that's enough for it at this point.
Fair enough. Gotcha. All right, awesome. So one thing just before, so I think you and Hugh both had some areas of agreement. And Hugh, just so you know, I'm muting you just because there's an echo for, yeah.
Oh, right, yeah. I can't hear, but that's fine, yeah.
Okay, so, but yeah, I just want to turn it to you guys. Before, you guys have mentioned certain features that the direct contact hypothesis just can't explain and that sort of thing. But just before we kind of go over that and confirm that, I'm kind of curious, have there been actual experiments using direct contact to try and replicate the Shroud images? And if so, how have those performed? Have they come up with the same problems you guys are mentioning? Or, whoever wants to answer first. Hugh, if you're going to answer, raise your hand and I'll unmute you. Okay, go ahead.
Yes, both Luigi Garlascelli and Joe Nickel tried direct contact mechanisms. I mean, there were lots of aspects that Bob's mentioned that they didn't address, in terms of just amount of paint and that sort of thing. But they certainly found that you could get a reasonably good representation of depth by pressing things down. But the point is not to use a body as a normal body. I quite agree with a lot of Bob's statements were that if we had a profile something like this, it's a bit exaggerated, it's just some bumps, and we put a cloth across the top of it and we folded the cloth down, then even though there would be perhaps less pressure down here than there is on the top, it would still, when it opened out, give you gross distortion. And this is why the medieval hypothesis is that it wasn't a statue, but a bas-relief. So if we look at this kind of profile and we press a cloth across here, then it's much easier for the cloth to sort of slightly indent and touch the bottom with a little amount of pressure, whereas it gets the top with a bit more pressure. And that's the kind of scenario that I think is more likely. And I agree with Bob that I don't like the distortions that would be obvious from something with a big vertical distortion, a big vertical change,
Awesome.
A big amplitude.
You're referring to the well-known Mask of Agamemnon or wraparound effect there, where if it was wrapped around or pressed down on the nose even.
Well, yes, and the other thing Bob mentioned was, of course, that a body has sides, and if you pressed it on the top, why wouldn't you press it all the way around the side? Well, of course, a bas-relief doesn't have sides, or not as such. It just comes to the end of the piece of wood.
Yep, exactly. And I promise you, we're going to be looking at your hypothesis and Luigi Garlascelli's artistic technique in the next Shroud Wars for our next image formation. But it's helpful to know that's why you guys have to use this bas relief for the face, because otherwise it's just impossible. Whereas
I quite agree with that. Yeah.
Okay. And what about experiments from people like Eugenia Natowski? She actually went to Jerusalem, from my understanding, and kind of experimented. Is that the case? You guys are looking.
I can't remember if she experimented with the bas relief or not.
Not with a bas relief. She kind of tested out direct contact mechanisms as well as others, right? Like, does a sweaty body create these images and stuff like that?
Well, there are lots of examples in which you can see. I mean, it's nearly always very obvious that the ears are so far apart that the thing looks ridiculous. Okay, gotcha. Okay, Bob, anything on your end regarding experiments using actual dead bodies or bodies coated in some kind of thing?
Yes, I'm not really familiar with that. I would mention here that the very best image of the Shroud has been produced by radiation controlled by information. And that the title on that paper was 2D Reproduction of the Face on the Turin Shroud by Infrared Femtosecond Pulse Laser Processing. It was published in 2019. And so that actually gives the best image of the face. So that, every other attempt to produce an image of the face is not as good. So, radiation controlled by information is the best example. And that's what my hypothesis is, radiation controlled by information. Now, regarding the bas relief, even on a bas relief, between the tip of the nose and the upper part of the lip is still a significant drop-off in height. And you can do this test In bed, just pull the sheet up over your head and see where the cloth resides. And you're going to have a significant gap. It's going to just fall off a cliff right here. And you're not going to be having contact because the fibers on the Shroud of Turin are not infinitely flexible. In other words, in order, the diagram there on the whiteboard is just a one-dimensional diagram or two-dimensional diagram. But of course, the face, whether it's a statue or a bas relief, is a three-dimensional configuration. So that you are still going to, if you tried to force it down and be in contact all the way down the tip of the nose, it's going to be creating folds on either side because the fibers on the Shroud of Turin are not infinitely flexible. So that those folds would then show up on the image itself. And that's not the case. That's just contrary to the evidence. So that didn't happen.
No, I think it is the case, and it's not contrary to the evidence. I mean, we do find that there are large areas of that sort of area where there is no, it's very difficult to pick out any kind of distortion at all, any kind of image at all. I mean, the image is very faint at the best of times. And certainly it fades away to nothing in substantial areas where the contact was such or where there was no contact. But the other thing is a bas relief. I'm getting a bas relief is not just a head sliced in half. The nose is very, very flat, so there is very little depression between the nose and the upper lip.
Even so, there would be non-discolored lines coming down where there were folds that have to take place.
Not necessarily. No, I mean, I don't know whether you've tried it, but linen is quite malleable. I mean, it does distort. Now, Joe Nickel, for example, found that wet linen was particularly good, and you could make a very good mold with no creases, because it distorts as you fold it down.
Okay.
Not infinitely. No, you'll always have folds, even on a bas relief.
No, we'll have to differ on that, but no, we don't.
So I'll move on because we're not assessing artistic bas relief in this show. This is strictly about a body.
We both agree that direct contact with the body would not be satisfactory. Although we might just give a shout out to Gilbert Lavoie, who explained all the blood as being by direct contact.
That's what I was going to say.
And then that the sheet then opened out and was flat for the image. It works particularly well with the face, but it doesn't work at all well with the arms and legs. So it's rather a very specified explanation for a very specified piece of the shroud, rather than a general explanation for the whole thing. But it's worth mentioning. That's the contact bit there.
Yeah, that's where I was just going to go, is to turn it over to you guys. What about direct contact with respect to the blood stains and explaining how all the blood stains and their features got on the shroud? Obviously, Hugh, do you think? Well, yeah, you go for an artistic approach. Do you think that direct contact could explain the shroud's blood stains in your view, or is there a problem with that?
No, I think nearly everybody. I mean, Bob's quite an exception. I mean, his explanation is ingenious, but he's very much the exception in thinking that the bloodstains are not direct contact.
But do you, because you think they were painted on it, and then do you think that do you agree with Barry Schwartz that it if it was from a body, it could have got on there from direct contact? There's nothing that would rule that out as a explanation.
Yes. Technically, yes. Although we do have the trouble with the bloodstains down the hair, which look like trickles down a firm surface, but in fact, the image of the hair it's just hair, and bloodstains don't trickle down hair. And Barry often thought in terms of Christ's hair being so matted with mud and sweat, and so that. I mean, he has long hair, he had a ponytail, and he knew how, after a day's forest playing around in the garden or something like that, his hair became more like a rope than hair. So personally, he thought that the blood could have trickled down the outside. But I'm not a great believer in that.
Fair enough. Bob, I'm interested in you because, as Hugh says, you have your own unique supernatural hypothesis that explains the bloodstains. Do you think that it's equally possible to explain the bloodstain evidence through just normal direct contact, or do you think we have to rule that out for some reason?
No, I don't think we have to rule that out. And I'm unique only in one sense, that I'm proposing an additional option for that would thrust the blood off the body as the particle radiation comes out of the body. That would naturally thrust things off the body and then onto the cloth. And so, yeah, I see that many locations of the blood would be due to contact between the body and the cloth. And that's very typical of others as well. That could be, and that would be the case for where there was blood coming out of the body while the body was in the tomb and wrapped in the cloth. Now, for other places on the body, the primary example of that would be the blood on the arms, because the blood that was on the arms resulted from the blood that was running down from the nails thrust through the wrist of the body, so that blood would then run down the arms while he was on the cross. And so he was on the cross for multiple hours, so that blood would have had plenty of time to dry. So the question is whether dried blood can soak into cloth. Now, you don't normally think that it would. Now, and you can do a simple experiment with this. You know, if you cut yourself in shaving, or if you get a bloody nose, just make use of the blood. Let it drop onto your arm, and then wait for 3 hours, and then put a Kleenex on it, and see if any of that blood would soak into a Kleenex or a piece of cloth. And I would suggest that that experiment would probably turn out to be negative. Now, Kelly Kearse has suggested that just humidity in the air could make the blood sufficiently moist in order to soak into the cloth. And I kind of doubt that you could get such pristine blood on the cloth by doing that. And so that I'm thinking in order to get such pristine blood on the cloth, that you should consider the possibility, and that's how I like to phrase it, because my expertise is not in blood. I'm trying to be an expert on carbon dating and maybe image formation to an extent, but I haven't gotten into blood so much. So I think we have to be flexible and consider all the options. And one option should be that the blood could have been thrust off of the body by the particles as they exit the body vertically collimated. So that would be an excellent mechanism to thrust the blood off the body, whether it's wet or dry, and onto the cloth, and thus arriving on the cloth in a pristine manner.
Okay, awesome. All right, so I've just got a couple of quick follow-ups for you guys on this blood question, because I'm not sure that natural direct contact could explain everything we know about the blood stain. So here's the first argument that I would want to put forward to you guys and see what you guys think. So number one, there are blood stains that are encoded that would be in non-contact zones. They wouldn't be in contact with at least a naturally draped cloth, right? And again, obviously, we have to suppose that the shroud wasn't wrapped tightly with pressure around the whole body, because otherwise we would get the sides of the face, we would get the sides, the body sides, and stuff like that. So there was some kind of flattening if that took place naturally somehow under direct contact hypotheses. So there would be non-contact blood stains that somehow got onto the cloth, and I'm not sure how that would take place. Again, even if they were and gently moist and that sort of thing, if there was some kind of pressure that somehow pushed up the cloth to touch these, wouldn't there be some evidence of smearing or some alteration of at least some of these blood stains? So that's kind of my first objection, why I don't think direct contact can work to explain these. What are your guys' thoughts on an argument like that? Yeah, Hugh. Yep, you're unmuted, Hugh.
Where are these blood stains, which are obviously from places which are where the cloth is not in direct contact?
So Mark Antinacci lists them in his book. I should have had it ready for me, but yeah, he lists various areas. I think on the legs, maybe the small of the back. I'm not. Yeah. Because he's hunched over, like some of the shoulders wouldn't be touching the cloth. So I think he's talking about scourge wounds and stuff.
Yeah. Well, yes. Yeah. I'm not totally convinced by that. I think perhaps yes. I can see that if the cloth is lying flat on the tomb floor and a body marked with scourge wounds is laid on top of it, perhaps the scourge wounds closest to the blood belt, perhaps he might think would not be in direct contact. Perhaps he's thinking of those, but various other people's ideas is that the shroud was folded up, was actually held in place with bands. I think Giulio Fanti thinks that the shroud was certainly followed the contour of the body all the way around the back. And I think John Jackson does as well.
Yes.
Because on the grounds that the knees are, if the shroud was flat on the ground, the knees would be so far away from it that virtually none of the back of the leg would image it, because they're more than 4 centimeters away. And I think that was a major obstacle to the shroud. The shroud lying flat and the body being very distorted on top of it.
Gotcha. Yeah. Bob, anything you wanted to say about that?
Yes, there's the issue of where the cloth was relative to the body, and due to the lack of wraparound effects on the face, on the shroud, that it's usually thought that if you follow that evidence, as we ought to, then that would seem to indicate that the top cloth, where the front image is now located, was some distance, some small different distance at least, above the body. And might be difficult to explain why that is. But also, due to the fact that on the dorsal image, the buttocks and the shoulders show no flattening, as they would, for example, if you put a body on a good thickness piece of glass and take a photograph from the bottom, you can see that the buttocks and the shoulders are flattened, but they're not flattened on the dorsal image. So that would indicate then that the body is some distance above the backside of the cloth where the dorsal image is now. So that we end up with a situation, if you follow that evidence where it leads, and that's all I'm trying to do here, is I'm trying to follow the scientific evidence where it leads. That the cloth above the body was levitated above the body, and the body was levitated above the dorsal side of the cloth. And so why would that be? And I think the best explanation for that is an electrical effect, because there's 4 forces in nature. There's gravity, which is the weakest, and the next weakness is electrical force. But I haven't looked this up, but it's probably thousands of times stronger than gravity. So that an electrical effect on the body and on the 2 claws would separate the top cloth above the body and the body above the bottom cloth. And that would only have to be the case during the image formation process, which I think was just a very small fraction of a second, microsecond or something. And so that the cloth could have been wrapped around the face, as Gilbert Lavoie suggests, and thus pick up the blood from the side of the face, which is then, when the cloth is then flattened out, is at a wider location on the face than the image on the face. And I think that's consistent, so that the cloth could be wrapped around the face prior to the image encoding event. But then, due to electrical static effects on the claws and on the body, that the top cloth is then levitated above the body, and the body is levitated above the cloth. Very, very strange phenomenon, but I'm simply trying to follow the evidence where it logically leads. And so I think that condition would be consistent, at least, with the evidence.
Okay, awesome. And I see Hugh has drawn something. Did you want to say something before that I ask my next question or last question on this?
Yes, only that a fairly sensible hypothesis is that the shroud is laid over the body, but of course it's flat on the bottom. But then, that being the case, you can see that the length of cloth between the buttocks and the ankles on the lower half would be a bit shorter than the length of the body between the equivalent places on the upper half, because the bottom goes straight across, whereas the upper goes up and down. And we don't find that to be the case. Generally speaking, we find that the two bits match quite well if you put them side by side.
Gotcha. Okay. All right. Cool. So
that lends a bit more. Sorry, that lends a bit more credence to the fact that the bottom cloth also followed the contours of the body, so there's less distortion.
Gotcha. Okay, cool. So my last question on this, and then I want to turn to the gas diffusion and Maillard reaction. So in terms of the blood stains, now John Jackson, and I do have the paper pulled up, he's written a paper where he's arguing that some of the blood stains possibly produced images of the blood on the shroud. So like some of the blood stains are encoded in the same way the body images are, according to him. So this is in his paper, Blood and Possible Images of Blood on the Shroud, if I've understood that. So I just wanted to ask, what is that about? If I've understood that properly, how could that couldn't be explained just through direct contact of the blood and the cloth? So yeah, what do you guys make of that from John Jackson?
I'll kind if you like.
Hugh.
I'm not sure that I understand him in exactly the same way, but it would be remarkable, and I think Bob would agree, for blood on a body to produce blood on a cloth which looked exactly and had the same chemical characteristics of the blood on the body by some other mechanism than not actually being blood, if you see what I mean. I mean, if it's some kind of blood image mechanism, then we wouldn't expect it to chemically resemble blood in quite the way it does. What do you reckon, Bob?
I think this is an area of further investigation, and there are so many, strange phenomenon that we recognize on the issue of the blood on the shroud, that we simply need to maintain flexibility and consider all the options and try and follow the evidence where it leads. Now, again, I haven't looked into this, but just off the top of my head, some of the blood on the scourge wounds would be blood that had coalesced inside the body and not exited the body. So that those may be what we're referring to when we're talking about some kind of the blood from the scourge wounds creating an image, and that might be might be. This is just off the top of my head at this moment. It might be explainable in the sense of an effect on the radiation, particle radiation that's being emitted by the body. But that would have to be investigated and thought through carefully. And so that, in my 10 years of effort on this, I really haven't even gotten into the blood. I started on carbon dating and got into image formation, but I really haven't gotten into blood extensively. So that remains to be done. A lot of these issues, we're in a situation that reminds me of the Missoula flood hypothesis that Harold, I think his last name was Bretz, postulated. It took him 38 years to convince other geologists that there was a huge flood of water, more water than is now contained in all of the Great Lakes, up in Missoula, Montana, that formed as a result of an ice dam. It took him 38 years to convince other geologists that explains the geological features of western Montana, Idaho, and Washington. And so I'm only 10 years into this effort, so I have another 28 years to go, I hope. This is going to take a long time because the evidence on the Shroud is so unusual, and that we do not have, the evidence itself, the Shroud itself, readily available for experimentation. So I think that the Pope, who is now the owner of the Shroud since 1983, when the older Lavoie family member passed away, willed the Shroud to the ownership of whoever the Pope was, so that at some point in the future, we are hoping and praying that whoever the Pope is at that point will recognize the need for additional testing with the much better techniques that are now available in non-destructive testing, because the last systematic experiments were done in 1978. So you can imagine the advances of technology in the last, what would be the 46 years, that we have much better experimentation techniques. In 1978, though they worked on it for 5 days, 24 hours a day, they did no experiments on radiation. And of course, that should be a major component of future testing on the Shroud of Turin. And so, we're hopeful that future testing will be allowed, and that the experts can come together and develop a systematic procedure for testing with the modern techniques that are available today.
Gotcha. All right, cool. So at this point, I want, because it's extremely related, I want to go to gas diffusion and look at the Maillard reaction, and see, first of all, what, go to each of you, get your guys' take on what the Maillard reaction is, and what are your thoughts on it as a mechanism, as well as what do you guys think of Kelly Kearse's most recent experiments where he takes into effect skin effects, which help out or work in conjunction with this Maillard reaction there. So yeah, Bob, you're unmuted, so I'll start with you on this one. Yeah, what are your thoughts?
Okay, yes, on Kelly Kearse's most recent paper on blood, I read it previously, a couple of years ago, I guess, but I just reviewed it just very briefly on the conclusions. And I think his experiments are interesting. Again, on blood, I think we need to kind of realize that we don't know enough about this. Like Einstein said, the more he learned, the more he realizes he doesn't know. So I think we need to be humble on this and try and be objective on all these different hypotheses. And there's a tendency for whoever develops a hypothesis then to think that it's his job to defend his hypothesis against everyone else's hypothesis. And I don't like that. I think, my philosophy is that we need to follow the evidence where it leads. And if new evidence comes out due to new experiments, then yes, if necessary, drop everything you've ever done and go with the new evidence. And if we don't get new experiments, if someone points out an area where you've been wrong in the past, and then we need to be big enough to admit, yeah, I guess I've been wrong. And that's okay, because I'm a human being, and I can be wrong. Scientists are human beings, we don't think of them as being human beings that can be wrong, but they can easily be wrong. My professor, unfortunately, my professor at the University of Michigan on the history of science said that all too often when someone comes up with a better explanation for a phenomenon, that he can't convince his peers that it's a better explanation until after they've died. So that's what it takes. It takes previous proponents to have died to convince them that your concept is better. Well, it shouldn't be that way. I mean, we should be able to think logically, but the problem is that all too often researchers become so invested with time and thinking that they understand their concept better and put in much more time on their concept than on the alternative concept. So they think that their concept has to be better. So that their position is they have to defend their concept against all the other concepts, which is unfortunate. It just takes a long time, I think, for a researcher to become sufficiently familiar with the other concepts. So, we have a Shroud conference coming up next year in, I think, the last day of July, the first 2 or 3 days of August, that we could spend all 3 or 4 days on that concept of that conference just on image formation and trying to understand what everyone else is saying and the pros and the cons of what you're saying and what others are saying. And so as to discuss it in an open fashion. We get kind of tied down to papers, and we're only limited to 20 or 30 minutes to present a paper, and you really can't get into the details of any particular image formation hypothesis in only 30 minutes. You'd need to have an open-ended conference where there's no set agenda, where each person comes in with their own proposal, and then it's just open to discuss all afternoon or all morning, so that you could spend enough time on it to actually get into the details and sort through these things, so that a researcher can say, yeah, I guess I was wrong on that.
Okay. And out of curiosity, what are your thoughts on the gas diffusion for the body images? Because I was citing Kelly Kearse's experiments were about he experimented on rats, I think, and he looked at the Maillard reaction, gas diffusion plus skin contact as a way to encode the body images. So do you have any thoughts on the gas diffusion or the Maillard reaction in general and what Kelly did there?
Okay, well, on my paper 39 that I'm preparing to submit, that my section 4 discusses a generic gas diffusion model, and then section 5 goes into the specifics of the Maillard reaction. And so Maillard reaction is a gas diffusion concept, so that a lot of my issues in section 4 also apply to my section 5 in my paper, what's going to be paper 39 on my website. But I list here 16 different issues with the Maillard reaction. Probably half of them are contradictions, and half of them are simply requirements that a robust hypothesis should explain that I don't think are explained with the Maillard reaction. So again, that gets into about 2.5 pages where I write it up. Could I just read the first one?
Yeah, you can list a few of them if you want. Go ahead.
Okay. Well, number 1, there are about 100 linen fibers in a linen thread. A linen fiber is about 15 microns, and I say this elsewhere. I think I've read something similar in the others. This generally applies. In diameter is about 1/5 the diameter of human hair. In a fiber that is discolored in one of the images, the discoloration on the fiber has a thickness of about 0.2 micrometers. Now, interesting, Kelly Kearse in his paper lists this as about 0.7 micrometers, and I'd like to investigate exactly why people are quoting a different value. The 0.2 value is the older value that people quote, though I'm not exactly sure why that value is quoted. I'd like to research that too. So it has a thickness of about 0.2 micrometers with the discoloration around the outer circumference of the fiber, so that the inside with a diameter of about 14.6 micrometers of the flax fiber is not discolored. I point all this out because this is the main problem on trying to explain the image formation, is explaining why the discoloration on the fiber is that thin and all the way around the fiber. And it's such a unique thing that I think it needs a unique cause, which I do propose in my image formation hypothesis, and that is I propose the explanation of what's called the skin effect of an alternating current. Not referring to human skin, but just the outer surface of a conductor when it has an alternating current flowing in. So if this discoloration on the image fibers were caused by a chemical reaction resulting from the diffusion of a gas from the body to the cloth, then it seems most likely this discoloration layer would have been much thicker than 0.2 micrometers, and it would have been thicker on the side of the fibers nearest to the body. The thickness of this discolored layer should also have been greater on the top layer of fibers in a thread than on the second and third layers of fibers. Reference 7, which is Ray Rogers' main paper, asserts that the superficiality of the discoloration was caused by evaporation of the wash solution, causing concentration of impurities, but is very doubtful that this process could result in a discoloration of less than 0.2 micrometers around the entire circumference of the image fibers. Just don't believe it. It's not credible. Reference 7, his paper, is aware of this problem. Quote, the hypothesis of gaseous diffusion into the cloth would have produced a color gradient through the thickness. Okay, that's kind of referring to another thing. Anyway, I just don't see it's credible. It's not credible for that to be the cause. And that's just one out of, I don't know, probably 6 or 7 different contradictions.
Awesome. And for the audience, I'll post up Bob's paper so you can read all of his 16 points there on this. But it's just before I come to Hugh, it's important to know, even Dr. Ray Rogers, who's the guy who made up this Maillard reaction as a hypothesis, admitted that it has shortfalls. It can't explain all the features of the Shroud images. But before we come to that evaluation step by step, I do want to go to Hugh for his opening on the, there you go, you're unmuted. So what's your take, Hugh, on the gas diffusion and the Maillard reaction? And what do you make of Kelly Kearse's most recent experiments on that front with skin contact?
I think they're quite interesting. I mean, he was particularly concerned in a way with how do you get a gas to come out of something and move across? What sort of gas might it be? Ray Rogers was hoping that it would be some kind of ammonia from decomposing urea or something like that as a component of sweat. And Kelly was sort of exploring along those lines, moderately satisfactorily. I want to pick up on a couple of things. Ray Rogers, his hypothesis depended on the shroud being covered with starch, which he said he found. I don't know what samples he was looking at the time, because this was, of course, much later, and in theory all the samples had gone back to the Vatican, but he must have had a few left over. And he said he thought he found starch by examining the fibers microscopically, whereas the Heller and Adler had also tested for starch, lots and lots of fibers, and found a negative result completely. And you're left rather, as Bob says, we've got to go back and have a look. I don't know how much we know about the whatever there is around the outside of each fiber. I don't know that we know it's discolored all the way around. I don't know that we know how deep the fibers go. We must remember that the only fibers we've looked at were almost adventitious. The pressure removing fibers off the shroud was so small that they could have come almost from anywhere, and whether they were actually extracted neatly, layer by layer, off any particular thread is extremely unlikely. However, sticking while we're on the gas diffusion hypothesis, one idea is that the gas would have diffused so much that all you would have got was a blur. A gas doesn't go, as most people who go for some kind of distance mechanism, it must be collimated. And there have been various attempts to try and collimate gas flow, as it were. So if, for example, there was a very strong temperature difference, then you might get, like hot air rises, the gas would rise, and perhaps it would then react with the cloth on the top before it then spread out and would lose its power to interfere with the other gas which had risen into the same place. It's difficult to say, but what we can see is one of Vignon's experiments, because of course he was the person who invented the vaporograph, and he did some experiments which were rather more satisfactory than I think most people think. And if I can just try and share my screen, can I go through this palaver?
Yep.
I'm going to go for settings. And now I've got, it's changed. I went for settings, but I'm not quite sure what I'm supposed to be looking at now.
Go to present.
Maybe it's not settings. How do I? Oh, it's present.
It's the present.
That's the one.
And then share screen.
Present, share screen.
And it should...
share screen. Yes, and then share screen. There we go. And
well, you have to tab. Select. Okay, yeah.
Screen. Right, choose. I'm going to go for entire screen. Yeah, let's go for the entire screen. We'll get all sorts of stuff to start with. And share. And what I want to share is this. Is this good enough?
Yeah, it looks like a face
several
turn.
times. Okay. Yeah. So on the left-hand side, we see a completely meaningless blob. But on the right-hand side, it translates into quite a recognizable bearded face turned slightly to one side. And this is what Vignon was using. Now, the reason I think it worked quite well in his case, whereas it probably wouldn't work with an actual body, is because this is quite small. I think this statue is probably, the way we're looking at it on a screen, about life size. But we can see that it does distinguish. We can see a beard, we can see a moustache, we can see the point of the nose, we can see an eyeball, and some kind of hair at the top reasonably well. So it's I'm stop showing now. It's not the case that the gas diffusion is not possible because it would diffuse too far and too widely. Well, it's not necessarily the case that it would diffuse too far and too widely. I think people dismiss Vignon's experiment without having really seen it.
Okay, yeah. It's,
that's all.
All right, gotcha. So, one thing. So I just want to kind of go through. Oh, Bob, yeah, go ahead.
Yeah, my comment. There are many different image formation hypotheses where people have tried to produce an image of the shroud. And they end up with something like this, where you can kind of make out a very fuzzy image. And usually the claim is, well, that proves how the image on the shroud could have been made. But I don't interpret it that way. I interpret it that proves how the image was not made, because of the dramatic difference between what's shown in these attempts and what's actually on the shroud. So that as I mentioned before, that radiation controlled by information has produced the very best image of the face on the shroud. And so, if anything, we should go with the option which produces the best image of the face on the shroud, which is radiation controlled by information. And that's what my hypothesis is.
Gotcha. Yeah. And on that front, I do want to just kind of go over with respect to direct contact and these gas diffusions. I want to just kind of mention some of the features, my minimal relevant features, and go over, okay, does it explain it? Do these theories explain it or not? So in the first place, photonegativity is my first one. I think you guys would both agree that direct contact and gas diffusion can produce photonegative images or quasi images. Yep, Hugh, do you agree?
Oh no, the one I just showed you had a rather good quasi photo negative image, in my opinion.
Yep.
I think it looked very.
Okay. Yep. Okay. Now,
that
Hugh,
image I just showed you was very good. Yeah, contact would be bad.
Okay. Now, I want to get your guys' take on the high resolution, because Hugh was just talking about this, and it is controversial from what I've seen, right? So, Paul Vinian, if you're using supposing lighter than air gases, then that's more problematic. I think Ray Rogers in the Maillard reaction was using heavier than air molecules, if I've got that correct from memory, kind of thing, right? So it's this helped.
I think it's more of a problem.
It's more of a problem. Okay, so gotcha. Okay.
Yes. So
the point is, if you've got a gas coming up here and it's heavier than air, it's going to mill around this area here and then slowly build up until it makes touch. And there's going to be just a complete smear. Lighter than air gases, especially, I mean, if you imagine it was little pellets of hydrogen, if you like, they'd just shoot up and touch the shroud more or less vertically. And when we say lighter than air, we don't really mean hydrogen. We mean gases which come from the body, which is considerably hotter than the surrounding air, so that they appear lighter than air, even though they may in fact not be.
Hugh, aren't they affected by like air currents and stuff that kind of mess? I thought there were certain currents that mess them up, and this is why Rogers wanted to go. Yeah, isn't that true? Don't the currents affect the lighter than air gases more so?
Well, it depends how breezy you think it is inside a tomb with a dead body and a sheet lying on top of it. I mean, it's not windy. The currents are going to be convection currents, or at least this is the hypothesis, that the currents are convection currents caused by the heat of the body.
Okay, Bob, you were going to say something there. So
yes, I think the question here is how many collisions there would be with air molecules, and so at normal pressure at sea level. Normal air has what's called a mean free path. That is the average distance between collisions. You can look that up. It's about 66 nanometers. So, which is a very small. Nanometers 10 to the minus 9th meter. So that even if there was only a 1 millimeter gap between the body and the cloth, a normal air molecule over that distance would experience about 15,000 collisions. Now, in each such collision, if we think in what's called spherical geometry, and I might lose some people on this, but such a collision can have an equal azimuthal angle of scattering on the azimuthal angle, but the polar angle can be forward scattered, and it usually is. So that a normal air molecule, for example, would be scattered forward rather than backward. But still, 15,000 collisions. After a certain number of collisions, a molecule that exits the body is going to lose essentially any characteristics that it had when it actually exited the body. So you might say that that atom or molecule then would have no memory of how it exited the body, whether in its speed or its angle or anything. So that after that point, after maybe 20 collisions or 100 collisions, whatever you want. I mean, because we're talking about at least 15,000 collisions. So that after that number of 20 or 100 collisions, the molecules are simply taking a path which is called a random walk path, which has no directional inclination at all. So that, in other words, a gas at that point loses all the capability of carrying information content. Now, to form a good resolution image, now good, we're talking about a few millimeters resolution on the Shroud, I think. You know, I've seen people talk about 4 to 5 millimeter range of resolution.
Yeah.
And I'm flexible with that. But after, with the molecules spending most of their collisions in a random walk path, they can carry no information from the body to the cloth. So that therefore, what we end up with is chaos of information as it's deposited on the cloth. So we end up with a blur. And I'm sorry, that's just the way physics works.
All right, so I see Hugh has put something to, again, the picture. Did you want me to share that, Hugh?
Well, I listened very carefully to what Bob was saying, and it is clear, and I agree with him, that the picture on the right-hand side doesn't exist, isn't possible, couldn't possibly have occurred. But it's there.
That doesn't have a good resolution.
Oh, it's not a very good resolution, no, but it's as good a resolution as the Shroud, if not slightly better.
Well, one thing is but you have to match even in terms of the what we see with the naked eye. Like this, you admit that this is nothing like the Shroud. The Shroud images, yes, they're diffuse, but they're not a blob like that. So like, wouldn't that rule out this?
No, they are. I think this is.
You think that's?
I think it's excellent. It's
the one on the left.
Yes.
Is comparable to the Shroud of Turin's face.
The one on the left is what we see. Is what actually is what we actually see.
Yes,
and indeed, the Shroud is. Yeah.
But both.
Obviously.
Oh, sorry. I think you're on a bit of a delay.
Sorry.
No problem.
The photo negative effect is extremely good.
Okay, but so I'm just going to grant that for the sake of argument here. But you have to match the Shroud not just on the negative, but you also have to match it in terms of the high resolution as to what we see with the naked eye as well. And even you are admitting this is pitiful compared to the resolution of the Shroud as seen with the naked eye. Like the Shroud man's face.
No. The resolution is exactly the same, whether you see it in positive or negative. How you recognize it is a question of your familiarity with the human form. But there's nothing magic about inverting an image to make it more resolved or less resolved.
Okay.
The Shroud image, even to the naked eye, is extremely unresolved. In fact, it's much more difficult to make out, say, the line of the moustache and the lower lip on the positive than it is on the negative.
Fair enough. Okay, so my last question before we move on to the next feature, this one's for Bob, because I hear what you were saying, right? So this is the paper by Kelly Kearse, where he's kind of adding on to the Maillard hypothesis and saying that the role of skin contact can help with this high resolution issue. And he did experiments on rats. Let me just bring up his results. If I where is it? Okay, there it is. Sorry, and I'll zoom in. Can you see that clearly there, Bob?
Let's see.
Can you guys see that?
Yes.
Yeah.
Yeah. So here's the experimental results that Kelly Kearse was getting. So it does create images and that sort of thing, and it creates negative images. And he was saying the role of this skin effect, like by skin effect, he's not talking about Bob Rucker. He's talking about like actual human skin or rat skin in this case, can help with the Maillard gas diffusion effect and create relatively high resolution images. Obviously, that was what Hugh was saying. So I just wanted to get from you, Bob, like, is this a falsification of what you were saying about the information being scattered by the collisions, or is there a way to explain this that is consistent with your objection to this as a mechanism?
No, I think it's entirely consistent with what I was saying. That this just proves that wasn't how the shroud was formed.
Gotcha. And is it because these images, they're not as highly resolved as the shroud? Is that the reason?
Well, yeah. I mean, we have a figure here, a feeder mouse. It looks like the feeder mouse is an early development form of a mouse, so that there's not a lot of detail on it, and so we end up with a blurry image that doesn't show the detail that's not there. So, I'm not sure what progress we've made on this issue.
Gotcha. All right, fair enough. So, okay, so I want to move on to the next issue, and this is something that neither of you guys, or maybe I missed it, but I don't think any of you guys mentioned it, and it's crucial. It's this issue of body image uniformity, right? So, not only are each and every single individual fibril colored relatively uniformly, but there's also this maximum density uniformity as well, so that the back image has the same maximal darkness as the front image. Now, if you're positing direct contact or even a Maillard reaction or gas diffusion, that's not going to be the case. The back image, just due to the effects of gravity, would be darker than what we see on the frontal image. And even on, I know Ray Rogers tried to address that, but we would have issues of liquids, decomposition liquids building up around the bodily orifices and that sort of thing. That that'll apply to a different feature. But what's your guys' take on the body image uniformity? Doesn't this rule out both direct contact and these gas diffusion mechanisms? Bob? Yeah.
Yes, I think that this feature of the shroud, that the front image and the back image have very similar characteristics. That's one factor. Another factor is that there are front and back images, but no side images. Those two factors, I think, are best explained by a hypothesis of radiation from the body that's actually vertically collimated. Now, there's several reasons for me saying that, but those are two things that I think do support vertically collimated radiation rather than contact or gaseous diffusion.
Gotcha. Hugh, did you want to speak to that?
Well, no, only in that almost any mechanism. I don't know about radiation, but the pressure of the body on the shroud, on the cloth at the bottom, is obviously going to be a lot more than the pressure of the body on any cloth that may be draping it. So even at contact points, there'd be more pressure. So you'd expect the back to be darker. So I just throw in Gilbert Lavoie again, who thinks that the image was made while the body was vertical, and that the collimation was not vertical, but it was horizontal, and that therefore both sides would be able to be equally dense. And that's one of the reasons why he's put forward that hypothesis.
But if you do that, you're conceding a supernatural miracle, a dead body levitating in a vertical thing.
I don't think he has no problem with that.
Oh, yeah.
I don't think so. I think both sides were made in exactly the same way, by either lying them on by lying a cloth on top of them, so that because they were both made in the same way, they produced the similar kind of darkness.
Gotcha. Okay, but you are, so for our purposes here, you're agreeing with us that natural direct contact and or gas diffusion, they can't explain this feature.
Oh no, I did agree with you. Yes, I do agree with you. Yeah.
Awesome. Okay, cool. So the next two features, you guys did kind of mention this in terms of the three-dimensional nature, the topographical information, as well as the vertically mapped wrapping distortions, the vertical collimation. Now, Hugh, correct me if you're wrong. I think you did mention that you think that some gases can reproduce this vertical encodation process. So number one do you agree that gas
I showed
diffusion?
you a picture of it. Yeah, I showed you a picture of it. Yeah.
Okay, but that wasn't vertical mapping. Wasn't the face on an angle and stuff?
Oh yeah. Well, that's because the face that he used was lying on a cloth, and then he put another cloth on top of it. I'll try and see whether I can bung that image in through ImageJ and see whether we get a vertical image out of it.
Okay.
What I would say, and I've only just thought about this, and Bob might answer it, is that when we look at the 3D image that we're so familiar with from the VP8 image analyzer and all that, it's a very flat image. I mean, it doesn't have the rotundity of a head. It doesn't even have the rotundity of a head that's been sort of sliced off 4 centimeters below the tip of the nose. It just appears very squashed and flat, rather like a bas relief, in fact, or a bas relief. So that the relationship, the height distance relationship, is not, to my mind, an obviously linear one if we are to take it as being from an actual 3-dimensional body. I don't know whether Bob agrees with that.
Yeah, Bob, do you think direct contact and gas diffusion can explain the 3D, also the vertically mapped, the vertical encodation path?
No, I don't see how those hypotheses could explain the vertical distance. You know, the 3-dimensional information that's encoded into the 2-dimensional image on the shroud relates to the vertical distance between the body and the cloth. That's the generally accepted view of shroud researchers. And so I'm not trying to invent new information. I'm trying to just take majority views and then follow the evidence where it leads. And so the one attractive thing to me to a radiation hypothesis, with the radiation coming vertically collimated, being emitted vertically collimated in the body, is that it automatically explains the 3-dimensional information that's on the shroud, because the radiation, as it exits the body, as it passes through various depths of air gap between the body and the cloth, will experience various amounts of scattering and absorption, so that information as to the distance that has gone vertically will automatically be encoded into the radiation, which is then captured by the body itself. So that every image we see, I don't know if people realize this or not, but every image that we see is due to information, so that we can see the image on the shroud, because the image that defines the appearance of a crucified man has been encoded onto the shroud, which that information is then carried to our eyes by reflected photons of light. A photon is the smallest packet of light energy. So that reflected photons of light then carry that information content from the cloth to our eyes. The back of our eyes then translate that information into electrical signals that transfer up our optic nerve to our brains. And our brains have learned to interpret that electrical information as the image of a crucified man, which that process is absolutely amazing. It's like we've been designed, which we have been. Yes, it's all about information. And there's 2 main issues, I think, with any image formation hypothesis. One is, how does it explain the extremely thin discoloration all the way around the fibers that are in the threads that make up the cloth? The second is, what is it that carried the information content from the body to the cloth, which was then deposited on the cloth? Because the information that defines the appearance of a crucified man was not in the limestone tomb. It was not in air in the tomb that was not in Peter when John looked at Peter in the tomb. No, it was only in the body. And that's why he could see the body and recognize it as a crucified man when he looked at it, because that's where the information is encoded in the body. And so that information had to be carried from the body to the cloth by something. And in our life, in our existence, the main source that carries information to our bodies, to our 5 different senses, seeing, hearing, taste, touch, and smell. The main source that's carrying information to us is photons of reflected photons of light. Carry information so that then we can see all the image around us. It's information that's carried to our eyes on photons of light. And so I'm saying that is what carried the information from the body to be deposited on the cloth. And so that information then controlled which fibers were discolored and the length of that discoloration. And that information was absolutely necessary. You can't form the image without that information being deposited on the body. And so every image formation hypothesis should explain how their concept carries the information from the body to the cloth to deposit that information that's required to form the images.
Gotcha. Hugh, I see you've prepared a diagram, so yep, you have a response.
Well, this is something that I've often wondered about, and I think it needs some sort of computer analysis, which was probably impossible in the 1980s, but which could be possible now. And that is that it's been assumed that the distance intensity relationship is a straight line. It's fairly well assumed that after 4 centimeters, there is no intensity. The image fades away. And yet the body doesn't look, as I say, like a sheet which has been lowered over the nose and then 4 centimeters below that, the body's been sliced off. It looks much, much flatter. And I wonder if that's because the relationship between the intensity and the distance may not be a straight line. And I wonder if Bob's thought about that in terms of your radiation. Does the radiation decrease entirely linearly with distance, or might it decrease either like that or like that?
Yeah, as far as I know in reading John Jackson's papers, the data is somewhat scattered. So it's most convenient to make the easy assumption of it being linear. But I don't know that necessarily has to be, but I think the interesting point here is that my computer code, MCNP, developed at the Los Alamos National Laboratory, can do that calculation. The only problem would be coming up with a sufficiently detailed model of the head. And I think that does exist as some of the items that are available to assist in running MCNP for medical purposes. So that would be a calculation that my computer code can do, but in my priorities, it might be a couple of years before I get there.
All right. Hang on, Hugh.
With authenticity here. Oh, sorry.
Sorry,
yeah.
you were muted. So yeah, just repeat.
Sorry, I'm working with the authenticists here in that the VP8 3-dimensional image is not very good, and I think that's because it treats the intensity distance relationship as being a straight line. Mm-hmm. If it wasn't a straight line, then I think the whole thing would be lifted off the background plane a bit more, and it might look a little bit more realistic, more like an actual body.
Yeah, that's an interesting idea, and I think it should be tested, probably with my computer code. I don't know how else that could be tested, but you need, in the radiation model, with radiation being initiated by emission in the body, then you need to model the collisions between each particle that's emitted and accurately calculate the scattering angle both azimuthally and in the polar direction. And my computer code is automatically set up to do that.
All right.
Yeah.
Awesome. Awesome. So, okay. So the last question I want to ask on this front. Okay. So body image superficiality, and I know that you guys mentioned this on the fiber level, right? There's a difference between 0.2 and Kelly Kearse was it who said it was 0.7 microns, but I just want to get from you guys. So do direct contact and gas diffusion along with the Maillard reaction and Kelly Kearse's newest work on that front. Can they explain superficiality, not just on the fiber level, but on the thread level? So it's only the top 2 to 3 fibers, also on the macro level. And the other thing I wanted to ask is, obviously with these gas diffusion, we're positing that the body is decaying to a certain extent. And I know that Ray Rogers said that, well, we don't need to posit that it's, totally decayed or something, but there would be significant amounts of decomposition liquids in the body orifices, right? Such as the mouth, the buttocks, stuff like that. And that should be detectable on the shroud, but it isn't. So I'm kind of curious, is that a falsification of these theories in your guys' view? So yeah, what do you guys, superficiality and the fact that there's no significant signs of decomposition liquids, does that rule out direct contact and these gas diffusion models? Who wants you? Do you want to go first?
Yeah, if you like. Yes, I think it does. The point about the gas diffusion model is that it's trying to get away from the supernatural. I think it's perfectly possible to posit a supernatural gas diffusion mechanism which overcomes all these problems. Mm-hmm. But the point about Ray Rogers is that he wanted to get away from the supernatural and suggest that this was a perfectly natural phenomenon. But I would find it extremely difficult to imagine any kind of dead body from which amine vapors evaporated from the hair, from the beard, from the fingernails, from every part of the body, including the mouth, as you say, the orifices, the nose, all did it exactly uniformly so as to produce the image that we've got. I would imagine there'd be some bits of the body be much sweatier than others, and they would be bits that decomposed, that produced more gas, and so in that particular area there would be greater image intensity, and so on. So yes, I think the image uniformity is completely ruled out. Rules out the gas diffusion hypothesis. It doesn't necessarily rule out the contact hypothesis, but there are plenty, because otherwise a contact is a contact. But that's ruled out by the distortion things that we've already mentioned.
Gotcha. And superficiality, just before I go to Bob, can it explain it on the various levels, the 3 levels?
My own view is that superficiality is much overhyped and under-researched. We're not sure how superficial everything is. However, I believe that a thing as tightly woven as the shroud, if you made a bag out of it and filled it with water, it would be quite waterproof for quite a long time. In other words, it's resistant to liquid, and the liquid would make a mess or would wet. The top would wet one layer, but it wouldn't necessarily wet the other layer until it had very slowly seeped through. Gas, on the other hand, would go through much more easily. And so I think I agree with you there that I would expect the image to be much deeper into each thread using a gas hypothesis than using a liquid or a solid hypothesis.
Or direct contact. Okay, Bob, same question to you on superficiality and about the no decomposition liquids on the shroud.
Yes, I think most shroud researchers accept that the biblical evidence for about 36 or 39 hours, maybe 36 hours in the tomb. Let's see, I'm kind of lost my train of thought here. Yeah, so that, in 36 hours, that you still wouldn't have a significant amount of body decay in the first 36 hours. so that the body would have exited the tomb prior to that. I think that's the general opinion. Now, the Maillard reaction assumes that there's going to be, just a very slight amount of body decay before 36 hours, and so that's going to be sufficient to create the images. Well, that needs to be tested. I mean, that's a major assumption that most people wouldn't really accept. Now, the other point here is that if you have a body wrapped entirely in the cloth, and the weave is fairly tight, then you're not going to be having currents inside that area. So that the gas, depending on the nature of the gas, it's either going to go up or down, but not both. And it's right. It's very hard to say that you're going to have some gases that go up and some gases that go down, because you have to form both images, and yet end up with images that have the same characteristics to them, the same quality to them. So that my concept here of image formation is that an oscillating nature of the process form both the top and the bottom image simultaneously by the same image process of radiation being emitted both vertically up and vertically down in an oscillatory fashion, sine wave or cosine wave, oscillating between up and down, vertically up and vertically down. So that you can imagine that in a normal gas being emitted from the body, it's going to have so many collisions that it's going to be moving in a random walk path, so that it's going to be diffusing to the sides just as readily as up and down. So you're going to get images on the side of the body as well. But they're all going to be chaos anyway. And you're not going to see any clear distinction, because the resolution is going to be diminished to the extent by the random walk path of the molecules. And so that's just the way physics works.
All right, cool. So
yes. So that a gas diffusion process is not going to work.
Gotcha. Okay. So yeah, I think that's it for direct contact gas diffusion. Before we move on to Dan Spicer's thing, is there anything I missed about those models that you guys want to share that you think is important? Anything about direct contact or gas diffusion that we didn't mention already? Or
yeah, I'd like to mention something, and this is, I've noticed this repeatedly amongst Shroud researchers, that there's a sharp dichotomy between two different types of researchers. And one type of researcher says that as an initial presupposition, before we start looking at the evidence, we have to assume that the images were formed by a natural process. That is, that according in their words, no miracle can be allowed, because that would not be scientific, blah, 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 blah.
Yep.
And I would like to take just the opposite view to that, because if the images on the shroud were formed by a natural process, what does natural mean? It's well known because it's repeated. We've seen it repeatedly. Like if you take a seed and you put it in the ground and you water it for 2 weeks and you get a flower, is that a natural process or is that a miracle? Well, if it only occurred once in existence, you might call it a miracle. But if it happens repeatedly and it's well understood and it's repeatable, you'd call it a natural process. Yet, according to Scripture, the laws of physics were established by God in the beginning, and they're maintained constant because God's nature is constant. So that God is involved in even a seed turning into a flower, even though it involves 2 weeks of watering in contact with the ground. So it becomes very difficult to even define what a miracle or a miraculous event or a supernatural event is. What really do you mean by it? I took my wife on Saturday to Costco, and we drove around looking for a parking space, and I found one right in front of the entrance. That was a miracle. What is that? What we mean by miracle? Or is a miracle a contradiction of the laws of science and is therefore logically impossible? Is that what we mean by a miracle? I don't think a person should use the word miracle or miraculous or supernatural unless they define what they're talking about, because people have different ideas as to what it means. And so a lot of people will say, we cannot accept a non-naturalistic explanation for the shroud. I'd like to take just the opposite view. If it's a naturalistic explanation that's needed, then there have been billions of people that have lived on the earth, have lived and died on the earth, and yet how many examples do we have of a piece of cloth that has the image of the body encoded on the inside of the cloth? Now, I did an experiment, and you could do this experiment too. I went into my closet and looked on the inside of my clothing. I went to my dresser and looked on the inside of my clothing, and lo and behold, none of them had an image of my body on the inside. My sheets don't either. And yet I've slept in thunderstorms where there was lightning. I've slept when there was earthquakes, yet there was never an image of my body formed on the inside of the cloth. So therefore, I think the better explanation here that we would expect it to be would be due to a process that is outside of our current understanding of the laws of physics. In other words, this is a unique process that formed the images on the Shroud of Turin. And this is so unique that it has never been investigated by science before. That's why it's unique. It's never been investigated. So therefore, this is a process that's beyond or outside of our current understanding of the laws of physics. Now, according to Scripture, Jesus' resurrection is just the first example of resurrection, and he's the first example of everyone, because everyone, according to Scripture, will eventually be resurrected for judgment. Okay? And so we should take that into account in our daily life. But in that sense, after everyone is resurrected, if you just go down this concept logically, we would then say that Jesus' resurrection is not a miracle, because billions of people have been resurrected with the same characteristics as Jesus. So, you have to be very careful when you're talking about what is a miracle and what is not a miracle, and what you're going to accept and what you're not going to accept. I think the better explanation that we should accept is an explanation that is outside or beyond our current concept of the laws of physics, because the Shroud of Turin is so unique.
Awesome. Well, the Christian in me is a little bit biased here. I'm not a neutral host. I had well said, Bob. I totally agree with your point on that front. But not so fast, because we have a couple more Shroud skeptics who say, actually, Bob, you're wrong. There is an ordinary natural mechanism that we can appeal to. And I'm just going to share my screen for a second just to show the paper. And this is, it's because of this mechanism I struggled with for a long time until I met Bob. But this is one of the reasons I wanted Bob here, is with his expertise. But it's Dan Spicer, hopefully that's showing up, Dan Spicer and E.T. Toton presented a paper called the Electric Charge Separation Hypothesis. And so this posits, again, a dead corpse being covered in the shroud, and essentially an electric field. I think it's a low energy, as opposed to Giulio Fonte, with the corona discharge, that's a high energy electric field, right? So this is just a natural low energy electrical field that enveloped the body due to an earthquake or a lightning storm or something like that. And that is what this electric charge separation effect, that's what caused the body images on the Shroud of Turin. Obviously with the blood, we already covered that during direct contact, because there are essentially only three mechanisms that can explain the blood stains. So if you take an artistic approach, you're going to say, well, the blood was painted on with a paintbrush. If you take one of the theories we're discussing today, an ordinary natural process, then you say it was direct contact, right? There's blood on the body and the cloth got there. And we already discussed that. And then you have supernatural alternatives like Bob Rucker's thrust hypothesis or Mark Antonacci's teleportation hypothesis. So we can kind of set the blood aside. We've already covered that. But with the body images, I'm kind of interested, and I'm going to start with you, on Bob, on this one. What is your take on Dan Spicer's electric charge separation mechanism? Because I have to admit, this looked good to me before I met you as a hypothesis. I thought it worked. So what's your take on this theory? What is it, and does it work in terms of explaining the shroud images?
Yes, I don't think it works. There's several problems to it, I think, which disqualifies it as a possibility. Just for example, I've only written down 2 problems in my paper at this point. I need to do some further work on this, but let me just talk about it a little bit. It assumes a weak electric field. And so where did this weak electric field in the tomb come from, in which the body and the cloth is located? And he doesn't propose a specific mechanism for this weak electric field. So that's a major issue where this hypothesis is lacking. He mentions several possibilities, but he doesn't go beyond that, just mentioning them. For example, a lightning strike might create an electric field in the tomb, but it would be extremely short duration, and it would not be long enough to produce any kind of an image. Now, I'll have to give credit to this concept. It's called electric charge separation hypothesis of Spicer's. And it does, I think, produce good predictions. So it would predict an experiment in which you create an electric field between 2 plates with positive and negative charge. And then you have something that you're modeling inside, maybe even a dead animal or something between 2 horizontal fabrics, for example, and to see if this would work to any extent possible. And I think it would not. But the first problem is that we really don't have any kind of a robust explanation for the electric field that's proposed. Secondly, here is that they model the body as a cylinder of metal. And they say, there's a sentence there that says the human body has excellent electrical conductivity. I thought, what? That's strange. And let me explain it just a little bit. If you're talking about a metal, say copper, or even better conductor, silver, but copper is normally used because silver is more expensive. But in copper, for example, why does it have excellent electrical conductivity? And that's because of the number of protons in the nucleus, thus requiring the same number of electrons in the orbits. Now, so there's the right number of protons that requires the right number of electrons, so that only 1 or maybe possibly 2 electrons are left in the outer orbit, which are then well shielded by the inner orbit electrons from the protons, so that these outer orbit electrons, 1, possibly 2, are not held tightly to that atom, so that they can transfer easily from atom to atom. And that's why there's excellent electrical conductivity in a metal, because the electrons are so loosely held in the atomic structure. But that's not true of the human body. What Spicer's talking about to try and create this illusion of excellent electrical conductivity is rotation of polar molecules. So, for example, in a water molecule, 1 part is a little bit more positive charge and 1 part's a little bit more electrical charge. So that Spicer's then talking about this electrical conductivity in the sense of just rotating the polar molecules of water in the body. Well, yeah, that's easily done by a weak electric field, but that's not an electric current. because no electrons are actually moving. They're just rotating with the molecules. And then the same thing with the supposed polar sites, charge sites on the cellulose molecules in the cloth. That, yeah, you can have sections of the molecules be slightly positive and some slightly negative. But in their diagram, in their paper, they assume that all of those charges could rotate in one direction. For example, all positive charges on the bottom of the cloth above the body, and all the negative charges rotate to the top of the cloth.
Sorry to interrupt. Do you know what diagram that is? I can show that on the screen while you're talking.
Oh, let's see if I can hold it.
Sorry, I didn't want to interrupt your flow, but I think it'll help people to see the visual.
Yes, I don't think I can get there. I'm sorry. It's their main diagram. But
Okay.
the problem here is that they are assuming that in this relatively weak electric field, that the fibers can all rotate in a fashion to produce all positive electric charges on one side of the cloth and rotate all the negative charges to the top of the cloth. I doubt that's going to happen. So at each point, there are assumptions that are made that I say, what? Why are you saying that? Oh, now this is an example here where what's being assumed is that the conductor, the black section, is the metal conductor, and the point here is the electric field lines that are shown in yellow there, that when they intersect the circle of the conductor, they come in perpendicular to the conductor. But that's not going to be the case on the human body. And so it really has no relevance to the issue. I say, get real. Doesn't work that way. So just get real. And when you get real, you're going to find it's not going to work. Okay, so that shows the polar compound. Okay, when you just went through, you want up a little bit more. Yes, you can see over in the far upper right-hand corner, the hydrogen molecules are at an angle to each other because of the locations that the electrons are circling in the carbon and hydrogen atoms. So they have to be at an angle to each other, which produces there to be a positive charge primarily toward the bottom on this diagram of the cloth where the two hydrogen atoms are located, and the top on the diagram would be a negative charge. So that's called a polar molecule, where there are charges. And the same would be true, probably to a smaller extent, on the cloth itself. But when this next diagram talks about if you have two charged plates and a weak electrical field between the two, the molecules are going to rotate so that the positive and negative charges on the water molecules are pointed in the right direction. Well, big deal. Yeah, I say big deal. That really doesn't prove very much. Yeah, that's going to happen. But then in the next diagram, I think is where it comes up to. Oh, okay. So here, and maybe go to the next one here. If you go to the next diagram. Okay, this is the one where we have. Yes, this is where the cloth represented by this twisted fabric is then rotated so that positive charges are on one side and negative charges on the other, and that's very doubtful. But yeah, and so he talks about a mean being released by the body, which is then attracted, and you see the upper right diagram there. Again, has a positive charge. A negative charge on the top part, and a positive charge on the lower part where you have the hydrogen atom. So that would also be a polar molecule. So he's trying to work with polar molecules and moving them in an electric field. Now, there's several problems to this. So the bottom cloth, this might be the top cloth, but in the same process, the bottom cloth would be repelling these molecules. So you need to have an electric field that's oscillating to create this. And that's not a lightning strike or an earthquake. So I don't know really how he's going to accomplish this. There's just too many problems in this. And so I don't even know if you were able to attract that one molecule to the one side of the cloth, why would it necessarily separate and deposit the one atom onto the cloth? You'd have to go through the details whether it would be even energetically feasible to do. And he doesn't address that. So these are all major issues to it. So as you get into the details, you recognize that this is just not feasible.
All right, cool. So we do have an audience question that Bob, you'll want to answer. Before we come to that, I want to give Hugh his chance for an opening, though, on the electric charge separation model that Dan Spicer and them have given. What are your thoughts on that, and how does it do in terms of explaining the Shroud images?
Oh, I agree with Bob all the way along the line. Basically, he's got two problems which he needs to find an answer to. And so he's come up with a possible answer, but that doesn't necessarily mean it's a practicable answer. Problem number one is vertical collimation. And problem number two is oxidizing the linen. That's all. And so he's decided that in order to oxidize the linen, he's going to use the oxygen from urea molecules, which have been, as Bob was explaining, spun round so that the oxygen reacts directly with the linen. And in order to get them from the body to the linen in a straight line, he's postulated this electric field. So, I mean, I think, yes, he's constructing ideas to fit these two problems. And I don't see them working at all myself.
All right, cool. So I'm going to bring up our good buddy Kevin Non-Tradicath. And okay, so the first thing, he has a few things to say. So the first thing he mentions is conductivity has everything to do with the distance of the electrons from the nucleus. It doesn't really have to do anything with the protons, other than the fact that the number of protons and electrons are usually pretty close. So, Bob, do you know what he's asking about, or what his objection is?
Well, that's just what I said. A normal atom is electrically neutral. So the number of electrons that are circling the nucleus, the center, the number of electrons circling the nucleus has to be the same as the number of protons. So
Gotcha.
An atom that is charged, that is where the number of electrons are not equal to the number of protons, is called an ion. So they use a different word for it. Yes, it's an atom, but it's been ionized by the addition or subtraction of electrons, so that atom is then electrically charged. So that the number of protons then has an effect on how the electrons circle the nucleus, because due to quantum mechanical effects, there are only a certain number of electrons that are allowed in the various orbits. So the inner orbit of a nucleus is only allowed to have 2 electrons. The next orbit out is only allowed to have 8. So that's 10 electrons. So an atom that had a full outer orbit with electrons would be, helium would be an inert gas that fills the inner orbit with 2 electrons. So that your inert elements are those which have entirely filled outer orbits with electrons. But so that would be 10, and I forget which element that would be, but that would be an inert element, and they don't react very well at all. So that, for example, if you had a nucleus with 11 protons in it, then you'd have to have 11 electrons for the atom to be neutral. So 2 of those electrons out of the 11 would go into the inner orbit. 8 would go into the second orbit. You'd then be left with 1 in the outer orbit. And that would probably be a metal, which could, where that outer orbit electron would only be held very loosely, and it could be transferred from atom to atom, thus being a flow of electrons, which is electricity.
Okay, now he responds to what you were saying. He's saying that, but the number of the valence shells is determined by the number of electrons, though, not protons. So positive ions will often have one few shell than their neutrally charged counterparts. Does that make sense to you? Or he has a...
Yeah, yes, that's just what I've said.
Okay.
That's what I've said. What I'm saying is entirely consistent with that. So
Okay.
that the way in which electrons fill the orbits depends on the number of electrons, which in a normal atom, the number of electrons equals the number of protons. So that the protons contribute positive charge, each proton having the same positive charge, and each electron having the same negative charge, as the proton is a positive charge. So if you, for example, had a nucleus with 11 protons, that'd be 11 positive charges in the atom, and there would then be 11 negative charges in the 11 electrons. So that would be, to the outside world, that would be an electrically neutral atom.
Gotcha. All right. Last one, and this one is actually a explicit question for you guys. So he came in the middle of the conversation, but he's asking, what do dipole-dipole bonds in water molecules have to do with the shroud?
I would say nothing, because this mechanism doesn't work. If this mechanism worked, it would have an effect. It would be important. But since the mechanism doesn't work, it's irrelevant.
Gotcha.
Yeah, I mean, the idea is that if there was an electric field and a lot of loose molecules, dipolar molecules around, they would align themselves along the field lines. Is that right, Bob? That's basically.
Yes, yeah. But so what?
Not quite. That's the answer to the question.
Yes.
Fair enough. He admits you guys are agreeing just with different words. So yeah. Okay, so I want to move on and kind of go over each of the various features of what this model can explain or not explain. So in the first place, photonegativity or a quasi-negative image. Could the electric charge separation mechanism explain that feature, do you guys think, or not?
Assuming it worked, we would have to assume that the urea molecules escaping from the body, because they're the ones that he's actually using, have an effect on the cloth in direct proportion to the distance they travel, and I'm not sure we've established that. Well, I'm pretty sure we haven't established that.
I think we've not established that, and I would think that there would be minimal interaction chemically between the urea molecule and the air itself. And yes, you're going to have scattering, but the urea molecule is not going to be altered by the scattering. So it'd only might be altered if there was a chemical reaction. And I don't know, but I kind of doubt that it would with the interaction with the air. And so therefore, you would not have this effect on the shroud.
Okay. And the next feature is this is one that Barry Schwartz told me is a plus for this. It's in terms of the high resolution images, because he thinks that this worked in conjunction with a Maillard reaction, and it was because of this electric field that it guided the gases to produce the high resolution images. Is that true? Can this mechanism, working in conjunction with the Maillard reaction as the coloring agent, would that create highly resolved images as we see with the shroud? Bob,
yeah, if you have no electric field, there'll be no effect at all. Okay, you need to postulate some kind of an electric field, a weak electric field, for this to function in any sense. And then you have to figure out some way to create an image, both the front and the dorsal images. And so, it's no good to just have a mechanism that forms the front image but not the back image. You have to form both. And so how are you going to do that? Well, you have to have, if it's by this electric field, then the electric field, it has to be oscillating. Well, it can't be oscillating, every millisecond, because the atoms take a while to migrate in diffusing. So it has to be a very slow sinusoidal, up versus down motion of the electric field. And what is it that causes that? I have no idea.
Gotcha. Hugh, anything on the high resolution, or you concur with Bob?
I agree with Bob, really. I think, yeah.
Okay. Okay, the next is body image uniformity. The uniform intensity of color on each individual fibril, as well as maximal density uniformity in terms of the back and the frontal images having the same maximal darkness there of color density. Can the electric charge separation explain those features?
Well, no, we've got the same problem as we had with the vaporograph thing. It depends on numerous identical molecules being found in an identical thickness layer all over the body, including the hair, the fingernails, and everywhere else, which is most unlikely in a natural scenario.
Gotcha. And Bob, you agree with that, or anything to add?
Well, I don't know. I'm just trying. This would have to be a very long process. It probably have to be acting over a large part of the 36 hours or so that he was in the tube. And the electric field would have to be very slowly oscillating between vertically up and vertically down. I have no idea what's going to cause this electric field. But then you're going to be able to get some deposition of the oxidation of the oxygen molecules. Maybe if there's a chemical reaction that would actually separate the oxygen molecule off of the urea molecule and preferentially attract it into the cellulose, which I doubt. So that, there are just so many problems with this. It's hard to hypothesize even the conditions that you need to consider for this.
Yeah. And I assume these are going to be similar issues in terms of the three-dimensionality and the vertically mapped. I know he specifically addresses the vertically mapped aspect and says, oh, well, the electric field, it's a curvy linear path and stuff. But I'm assuming, no, it wouldn't explain these features. Is that correct, Bob? Even if it creates...
Yes, well, if you take this hypothesis and realize that the body is not modeled by a metal cylinder, so that the curvature on these lines of electric field are going to be much different than the hypothesis. But in any sense, what's going to happen is that the motion of the urea molecules from the body would create a wider face on the cloth than exists on the cloth. The correct width of the face can only be formed by something that is moving straight, not in a curvilinear fashion. It has to be moving straight and in a vertical fashion, like vertically collimated radiation. And that's the way I reason this out. So that the image on the face is a normal width of the face, which then disproves this curvilinear motion of molecules from the body. This would also disprove Giulio Fante's concept of corona discharge, also following this curvilinear path of molecules.
Awesome. Hugh, I take it you fully agree. I saw you nodding there. No, you disagree? Oh, hang on. I'll unmute you.
Sorry, that's a nod. Yep, he's exactly right.
Okay. And what about body image superficiality on all three levels again? And how would this mechanism perform on that front? Is it any better than gas diffusion and direct contact?
It is a gas diffusion.
Yeah, this is a gas diffusion. So
we're talking.
go ahead.
We're talking of the urea molecules as as if it's a sort of gaseous urea. And although, as I say, I think the weave of the Shroud would make remarkably waterproof for quite a long time, the gas would just go straight through it. And so the any kind of reaction you'd expect to find all the way through, or much deeper than just the surface.
Fair enough. Yeah, and I misspoke there. I just meant like a pure gas. This is kind of like gas diffusion plus this electric field. So that's what I meant. But yeah, Bob, on superficiality, I saw you saying no, it wouldn't do it, and that's on all three levels, right?
Well, that's true. If we're talking about electrical charges, electrical charge, the force of electrical charge is much stronger than gravity. I don't know what it is, 1,000 times stronger. It's much stronger. So that these urea molecules would be attracted to the electrical charge, the way he has it configured, assuming that it works, would be attracted to the top fibers. Well, and maybe less so to the second layer of fibers, and less so to the third layer of fibers, so that the coloration of these fibers would be much different. You'd have the denser color on the first layer, and then it would get lighter and lighter. And that's not consistent with the evidence. So the superficiality doesn't work in that sense.
Gotcha. Okay. And obviously, none of these mechanisms would explain the bones. I don't consider that a minimal relevant feature, but if it's true that there are bones and teeth shown, obviously none of these mechanisms would explain that. That should be said. Hugh, you would definitely agree with that. If it's a fact that there are bones and teeth, none of these natural mechanisms could explain that. Correct?
All the mechanisms that we've looked at seem to rely on things which come from the surface of the body, relatively in uniform amounts. If it's a painting, the body is covered in paint. If it's a vaporograph, then the body is covered with some kind of liquid, and that's all uniform. But it's all from the surface. It's not something that bubbles up from inside.
Gotcha. Okay. I think the last thing I want to ask about is, okay, so obviously, I know Hugh disagrees with this, but one of the features is that there's no body images under the blood stains and that sort of thing. So I'm just kind of wondering if the electric charge separation hypothesis is true. Let's just suppose it was true. Could that explain that feature, or would it have any effects on the blood stains in any way, right? Like, would it cause damage or anything to the blood stains if this mechanism was true?
Unknown. There's so many unknown things about this. Would the molecules that would be attached due to his hypothetical electric field then prevent an image to be formed, or the discoloration to form, when blood is present? I don't know.
Fair enough. All right, Hugh, on your end,
I could only speculate that all this by the polar oxygens slamming into the molecules of hemoglobin would tend to oxidize it more rapidly even than before, which would tend to make it less red rather than retain its redness.
That's a good point.
Yeah, Dale, I think there is one important issue. It's often said that it's been proven that the blood transferred prior to the mechanism which discolored the fibers. And that was because if the blood is removed, there's no discoloration found underneath it. But I don't think that conclusion is necessarily the only one. It could be that there's a chemical process of the blood which prevented the fibers from discoloring over time, because it's also usually assumed that the discoloration of the fibers actually occurred over some time, whether days or weeks or months or even years, possibly due to it being held up in public in showing the shroud with exposure to ultraviolet light. And some of the reason for that comes about by Art Lynn's experiments with proton irradiation and his need to actually heat the samples in an oven to simulate the passage of time, which then finally, with the heating, displayed the discoloration.
That makes sense. Good point. Yep. Hugh, you had any? Sorry.
True. That's true. Yep, I
Okay.
agree with Bob there. Yeah.
Awesome. All right. Well, that does it. In terms of the electric charge separation model, I'll just turn it to either of you. Is there anything that's really important about this model that I've missed or haven't asked about that you guys think is important? No.
I'm tired of talking.
You're tired. Okay. Yeah, you're in Texas. So you need a break. Hugh, you're good on your end as well.
Yes, I mean, I find it difficult and not necessarily terribly useful to spend a lot of time picking apart a rather ad hoc explanation for something that's not been experimented with, and it's sort of couched in lots of scientific terms, but it just doesn't seem very likely.
Fair enough. All right, cool. Well, with that said, I think I will end us off. I think we've kind of given a good go at these various ordinary naturalistic theories. That this is literally everything in terms of this category. I've been very thorough in terms of covering these image forming mechanisms, especially in this category. So yeah, and we covered all of the supernatural mechanisms, the radiation theories and that. So I only have one more Shroud Wars on the image formation, because I've covered all the ordinary artistic mechanisms with one notable exception, and I've saved it for last on purpose. It's Luigi Garlascelli's powder rubbing hypothesis and Hugh Farey's quem queritas hypothesis, which are related. So that's what I plan to do on the next Shroud Wars image formation panel review, and that will complete our survey of assessing every single known hypothesis for explaining the Shroud images, either artistic, natural, or supernatural. So, but before that comes up, next week, actually, I'm going to be switching back to Shroud history because I did a panel review with Hugh on panel review part 4. And unfortunately, it didn't come out the greatest. We had technical issues, and I tried to cover too much history from 30 AD all the way up to 1204, and it was too much for one show. So we're actually going to be breaking it up into 3 or possibly 4 shows, breaking it up into various manageable periods. And next week, Hugh will be joining me with Dr. Cheryl White and Jack Markwart to look at the period from 30 AD to 500 AD. What are the historical documents supporting the image of Edessa versus the image of God incarnate hypothesis? So look out for that. And yeah, everybody have a great week. Kevin, you have a great week. Yep. Cheers. Thanks for that. And yeah, take care, everybody.
Okay.
Thank you for